Alright, so welcome back. So in the last video, we looked at an AC review. So remember back to the previous video, we talked about AC is what we call alternating current. Because every half cycle, AC, the current, is going to swap directions. So remember we talked about what we call the upswing and then what we call the downswing. So this is just kind of expanded into that. So now we're going to look at what diodes look like in an AC circuit. So one thing is we've already talked about diodes in the DC world. So diodes in the AC world are primarily used for what we call rectification. So rectification means that we are changing a signal or changing a quantity. So what are we rectifying? Well, we're rectifying AC to DC. So if you remember, diodes will allow current to flow when it's forward biased, but when it's reverse biased, what happens? It blocks the current. It's an open. So it uses that to its advantage to more or less reroute AC to only flow one direction. And if AC is only flowing in one direction, then what do we technically have? We have DC. DC's direct current. Current only flows one direction in DC. So that is the whole use of a diode in an AC application. Okay? So, like I said, we're taking baby steps here. We're eventually going to get to a full-blown rectification circuit. But today, we're just going to talk about what we call positive clippers and negative clippers. So this is just kind of the foundation or the starting point of rectification, and taking that AC signal and converting it into, instead of bidirectional, unidirectional, okay? All right, so let's talk just a little bit about this circuit. So remember in the previous video, we said that this is our AC waveform, okay? And in this circuit, all we have is one resistor and one diode. So in the next series of videos, in a couple of days, we're going to get a little bit more complicated than this, but this is just a basic resistor diode circuit. So what we want to look at is what this would look like on an O-scope, okay? So one of the most valuable tools that you guys will use to troubleshoot any electrical circuits is the oscilloscope. So the oscilloscope allows you to look at outputs. And I can't stress this enough. When you look at circuits, it's just as important to know how to do them numerically and to look at them visually. Because an oscilloscope allows us to look at a circuit visually. We observe the output. We want to see what the output looks like. Not necessarily numerically. The numbers do play a huge part in it, but also realizing what you're seeing as an output. What does your waveform look like? Are you supposed to have a sine wave? Are you supposed to have a flat line somewhere? Okay, so that's what we're going to more talk about in these next couple of videos. We're going to be more or less analyzing the circuit and observing what the output would actually look like. And then next week, once we come back, then we will be actually building these circuits and proving all this on an oscilloscope. And then what we're going over here on the board, you will see on the oscilloscope. All right, so let's look a little bit at this circuit here. So I have a resistor that is 1 kilo ohm, and I have a diode, and this is a general purpose diode. So remember, when we're talking about general purpose diodes, how much voltage do we need to start conducting in forward bias? 0.7 volts. And then remember, in reverse bias, we're going to read open. Okay? So, with that being said, let's look, and I'm going to ask you guys just one question. I want you to pause when I ask the question. I want you to think about it for just a second and answer it. See if you answered it right. So, is this circuit here forward bias or is it reverse bias? So remember, in order to be forward bias, the anode has to be more positive than the cathode. Okay? So, I'm going to ask again, is this circuit forward bias or is it reverse bias based on what we've done before? All right, if you answered forward bias, you are correct. If you answered reverse bias, you are correct. Kind of confusing, huh? Well, here's the deal, okay? So this is why it's both. It depends on where you're at in the waveform, whether it's forward bias or if it's reverse bias. Okay? Depends on where you're at in the waveform. And here's why. Remember, AC every half cycle changes. So on the upswing, it's going to be one type of biasing, and on the downswing, it's going to be another kind of biasing. Okay? So, let's look at let's just look at the circuit, okay? So, remember what we talked about in the previous video. We talked about on the upswing, the polarity looks one way, and on the downswing, it's another way. So first, let's go ahead and let's give a voltage. We're going to say that this is 15 volts peak. So first, I just want to go ahead and I want to draw Vs here. So what I'm going to do is I'm going to take and I'm going to draw what my waveforms would look like here. This is just a 15 volt AC source. So that means that this is just going to be a sine wave that is 15 volts peak in either direction. Okay? So it's 15 volts in either direction. It's just a sine wave. We have not did anything to this sine wave. This is our input. Okay? So, here's my upswing and here's my downswing. So, let me ask you a question. On the upswing, this is my positive, and this is my negative. So, on the upswing, is the diode forward bias or is it reverse bias? Anode is positive, cathode is negative. So that means that on the upswing of things, this is going to be a forward bias circuit. And then on the downswing, polarity swaps. And now it's a reverse bias. So this is going to be like an open. Okay? So what have I just done? I just blocked current. So on the upswing, current is allowed to flow because it's forward bias. And on the downswing, it's not allowed to flow. So in the most basic form, and I'm going to show this to you visually up here, I just created DC. And there's a lot more to it, okay? A lot more to it. But we will get there. But in the most basic form, I have just taken AC and rectified it to DC. And later on down the road, we'll get into technical names, but this is what we would call a what we call a half-wave rectifier. Okay? Alright, so let's look at what everything would look like. So again, let's just remember, and I'll write it out here to the side, that on the upswing, equals forward bias, and on the downswing, that equals reverse bias. So that means at forward bias, on the upswing, the diode is going to conduct at 0.7 volts, and on the downswing, it's going to read open, so open would be 15 volts, okay? So that's what the diode looks like, okay? Mind you that this is the diode I'm talking about. On the upswing, forward bias, so it reads 0.7 volts, and on the downswing, it's reverse bias, so it's like it's an open, so I'm going to read source voltage, okay? Just like in the DC world, except this is acting as both. It's acting as forward and reverse bias. All right, so let's look at what the waveform would look like across VR1. Okay, so across VR1. On our upswing, is the diode forward bias or reverse bias? It's forward bias. So that means on the upswing, this is going to be locked at 0.7 volts and current is flowing. So if I have 15 volts total and 0.7 volts is here, what is here? 14.3. Because we can say that VR1 is equal to 15 minus 0.7. Okay? So that means that on the upswing, I'm going to come up and I'm going to label this positive 14.3 volts. Very important, always label your voltages on your waveforms. So remember, I'm not looking at what it looks like across the diode in this particular waveform. I'm looking at just the resistor. So think of it like this. This is where my O-scope is connected. Okay? All right. So on the downswing, when current starts traveling in the opposite direction, okay, this is my polarity. So that means that it is reverse bias. So if it is reverse bias, how much is here? Source voltage, 15 volts. Because remember, in reverse bias, current is not flowing. And if current's not flowing, and it's open, how much is across the resistor? 0. Because remember, in an open circuit, current is being blocked from going in that direction. So that means it's going to be a flat line. Okay? So that means that this is where I'm seeing that DC. This is where I'm seeing that DC at. Because if you look, basically this is just a half-wave rectifier. I'm allowing current to flow in the positive direction, but when it tries to flow in the opposite direction, it's not allowed to flow. All right? So, essentially, current's only flowing one direction here. So that's why I say in the most basic form, this is DC. Okay? So now, what would we look like across the diode? So now I'm going to take and I'm going to place the oscilloscope leads here. So now I'm just looking at what the diode looks like. All right? So, on my upswing, the diode is forward bias. So it is locked at 0.7 volts. So that means that I'm going to take and I'm going to clip in the positive direction at 0.7 volts. Now this needs to be a flat line because you are essentially just cutting the voltage off, slicing it off at 0.7 volts. Okay, so across the diode, it's going to lock at 0.7 volts. Now, on the downswing, it becomes reverse bias, and it reads what? 15 volts. We're going to drop down, and that's going to be a positive 0.7 and a negative 15. Then I'm going to draw a couple of cycles of that. So, I want you to realize something here. I want you to realize something. If you take VR1 and VD and you slide them together, you're going to have this. That's one way in this kind of configuration that you know you are correct. Okay? Because look at this. I have 0.7 volts here and 14.3 here. If I slide those two together, what do I have? 14.3 plus 0.7 is 15. I'm 0 here because I flatlined. But what am I right here? 15. So essentially, if you slide those two waveforms together, you get the complete waveform here. Okay? It's a series circuit, so just like anything else, voltage adds up. Okay? So just remember, on the upswing in this configuration, on the upswing, I'm forward bias, so it locks at 0.7 volts, and on the downswing, I read open. And you just have to kind of play into factor of what that resistor looks like. And it will look like this on your oscilloscope. Okay? So if you have any questions, please let me know. So what I'm going to do really quick is we're going to look at what a negative clipper would look like. Okay, so what we're going to do is we're going to turn the diode around. Okay, so all I have done is I have turned the diode around. So just like the previous one, this is going to act as both. It's going to be both forward bias and reverse bias. However, the upswing and the downswing is going to change. So what you're going to see, long story short, is all of your waveforms from the previous circuit are just going to be flipped. Okay? So let's look at this. And this is what we are going to call a negative clipper. Okay? So, again, VS is always going to be just your typical sine wave, and it's labeled whatever your source is. So positive 15 and negative 15. Okay? So, let's look at what VR1 and VD is going to look like now that this has turned around. So let's look at what we have. On the upswing of things, this is my polarity on the upswing. Anode is negative, cathode is positive. So remember, this is reverse what we had last time. So on the upswing, is going to be reverse bias now. And then on the downswing, when my polarity is this, the anode is now more positive, so it's going to become forward bias. So on the upswing, I'm going to read open, which is 15 volts, and on the downswing, I'm going to be in forward bias, so I'm going to read 0.7 volts. So what you're going to end up seeing is the waveforms just flipped around. Okay? So, on the upswing, across the resistor, on the upswing, remember, this is my polarity. On the upswing, I am reverse bias. So this is an open circuit. So if I'm an open circuit, is current flowing? No, it is not. So that means that I can't have voltage across the resistor because all the voltage is dropping across the open. So I'm going to start out with a flat line because on the upswing, I'm not allowing current to flow through that resistor. So now, on the downswing, when this is my polarity, now I'm forward bias. So the diode is going to be locked at 0.7, and if I have 0.7 here, what's left here? The 14.3 volts, which is left over to add up to get your 15. So on the downswing, negative 14.3 volts. So if you look from my original source here, basically what I'm doing is I'm now only allowing current to flow in one direction again. However, it's just opposite of what I had the first time. So what do you think the diode's going to look like? So if I'm looking primarily at the diode, on the upswing, what is it? On the upswing, it is reverse bias. Okay, so on the upswing, it's reverse bias. What does a diode read when it's reverse bias? It's open, so it's going to read 15 volts. It's going to read source voltage. And then on the downswing, it's 0.7 because it's forward biased. So on the downswing, I'm going to lock at negative 0.7 volts. So again, I can take and just slide these two together. Negative 0.7 plus negative 14.3 is going to give me negative 15, which is what I have here. And then this is 0, and this is positive 15, so that gives me my positive 15. So slide these two waveforms together, and they will equal the source voltage. And this is what we call a negative clipper, because the diode is clipping in the negative direction here. On the other one, it clipped it at 0.7 in the positive direction. So that's where I get negative and positive clipper. Okay? So that's about all there is to just the basic foundation of AC. So just remember, always just remember what your upswing and your downswing is. If you have to memorize what the polarity is on the upswing, which is this, and then memorize it on the downswing, which would be this, up and down, and then figure out whether on the upswing the diode is forward bias or reverse bias, and then determine the same thing on the downswing, and then just draw your waveforms accordingly. Okay? So I'll give you plenty of practice with this. A worksheet is coming. I'll try to give y'all timely feedback on that. The tests are currently being graded. I'm not releasing any of the test grades until I get them all done. But I should have them done by tomorrow, which is Wednesday. I will have them done by tomorrow, okay? So if y'all have any questions, please let me know. Please remember to keep turning in your work, and please submit it through Blackboard, not by email unless you mess up, and if you submit the wrong one, then please just let me know ahead of time, and then you can send it through email. Please try to get it submitted in Blackboard because it's way easier for me to grade that way. All right, so y'all have a good rest of the day. Not too much longer before we start meeting in person, and I understand that is going to make it so much easier because any questions about all this I can answer in person. We can work some on the board during the lab time, so you guys just hang in there for another week, and then we'll be back in person, and hopefully everything will kind of smooth out from there. So anyway, until next time, stay healthy, stay safe, and I will see you guys later.